My name is Cédric Serugendo. I work at the Crem Research Center. I'm participating to the EnerMaps project as a developer. In this demonstration, I will present you the EnerMaps gateway and the EnerMaps data management tool. Let's start with the EnerMaps gateway. On the central part of the platform, we have the main section. This section is made of several tabs. The first one briefly presents the EnerMaps project and its issues. We can also find key roles illustrating the field covered by this platform. The second tab lists publications. The question marks appear because the platform performs a global search, so it happens that the results are in different alphabets. The third tab lists the research data. The fourth lists software. The second last one lists all other scientific publications. And the last one lists the datasets that have been selected and reviewed by experts within the EnerMaps project. These datasets present the available information in a raw way. It is possible to perform a more detailed search. To do so, we can perform a keyword search using the search bar. For example, let's perform a search on heat demand. We obtain a list of results that can be refined by applying filters. The filters available are access mode, result type, year range, founder, and so on. Let's assume we want to get only research data. Now we have a smaller list. We can select a result to get more information about it. We are now on the page dedicated to the dataset. We can browse it for more information. There is also the possibility to download this dataset locally if needed. As I said before, among of data available on the platform are the 43 datasets reviewed by the project partners. These datasets have the particularity to be directly visualized on the data management tool. To do this, we must go on the EnerMaps tool tab and follow the link. For the moment, we are on the beta version of the gateway. In the next version, we will be able to go directly to the data management tool thanks to this link. It is also possible to go to this link from the home page. To do so, we must go in the Filtered Dataset tab. Here, we get the list of the 43 datasets as shown earlier in the presentation. We can directly access to the link to the data management tool. The data management tool is a cartographic visualization tool. It is naturally made of a map background on which you can navigate. We can move on the map, make a zoom out to get an overview, or make a zoom in to get more detail. We can display the layer we want to see. For that, we must choose among the 43 datasets that are available on the platform. Let's assume we want to get information about wind power. We can use the layer search bar to find the right dataset. In the upper part, we found the top navigation bar that contains useful links for future users, such as a link to the Project Wiki website, to the EnerMaps gateway, and to the Kailo community. There is also a search bar. By entering the name of a place, we can directly move there. Let's take the city of Lausanne as example. The data management tool also embeds an analysis tool, the calculation modules. We can find the available calculation module just there. We can see that the calculation module window is separate in several sections. Each section is identified by the name of the calculation module, and the calculation module section has a form to be filled in to run the calculation modules and a button to run the calculation module. These tools allow a first analysis of the layer available in the platform. To perform this first analysis, the calculation module needs a layer to analyze, a region framing our study, and possibly some input parameters. Let's take calculation modules heat demand as example. This calculation module calculates district heating potential within selected region using two threshold values. The first one is minimum heat demand in each area. The second one is minimum heat demand in district heating zone. Zones within the selected region which fulfill this condition are written as potential district heating zone. To define area we want to study, we can draw a polygon. For this, we can take the option selection in the area selection window and we define the point belonging to this polygon. We can also select nuts and low. The nuts and low corresponding to the territorial division defined by the European Union. After the area selection, we can then select the heat demand map, which is the layer expected by the calculation module. After that, we define the minimum heat demand in hectare at 500 megawatt hours per year, which is the widely used calculation value in Switzerland. Then we define the minimum heat demand in district heating area at 30 gigahours per year. We launch calculations for the selected region. We obtain indications such as total district heating potential and total heat demand. The potential of each zone is represented in chart. Let's take a second example by changing the NUTS level in the city. For example, let's try it for the city of Geneva. We can see that here, with the same input parameter, we get more district heating potential. future version of the platform, this zone will be visualized as a layer directly in the platform. With the data management tool, it is possible to visualize and manipulate layers. But if the user wants to have more information about the layer, he can easily go to the corresponding EnerMaps gateway page through a simple link. So we come back to the dataset page. I thank you for your attention and your time. I remain at your disposal if you have any question. Thank you.